Hi there! Welcome to our channel where we delve into fascinating topics on sustainable living. In our previous video, the environmental impact of the fashion industry and offered some tips to make your wardrobe more sustainable. We have a question for you. The fashion industry consumes 4% of the annual freshwater withdrawals, ranking second in the list of the highest water-consuming sectors. So, do you know what industry stands at the top? Yes, it's agriculture. Today, let's together explore the impact of agriculture on the environment and discover some tips to make our eating habits more sustainable. This video is divided into two parts. In the first part, we delve into the impact of agriculture on the environment. Armed with these insights, we transition to part two, where we present sustainable solutions. Now, let's dive in. In ancient times, our ancestors made the choice to settle in the most fertile areas, establishing family-centered communities. They selected climates and soils conducive to plant and animal growth, prioritizing proximity to freshwater resources. Fast forward to today, our preferred living spaces have evolved. Modern cities may not boast naturally fertile soils, pristine water sources, or pure air, but they excel in providing essential services and access to resources transported from elsewhere, whether through pipelines, freight, or other means. Agriculture played a pivotal role in the advancement of human civilization. It marked the transition to settled life as farming of domesticated plants and animals generated food surpluses, enabling the formation of cities. Agriculture encompasses crop and livestock production, aquaculture, forestry, and the cultivation of non-food products. These non-food items serve various manufacturing needs, such as providing fibers for clothing and bamboo for construction. Agriculture is the backbone of both urban and non-urban centers, essential for sustaining communities worldwide. The ever-expanding global population has compelled agriculture to evolve and meet the increasing demand for food. Throughout this developmental journey, agriculture has left its mark on the environment, manifesting both positive and negative aspects. Now, let's delve into the positive contributions. Initially, mitigate carbon dioxide levels in the atmosphere by sequestering carbon in soils. Techniques like permaculture and the cultivation of tall-growing plants, such as bamboo, facilitate crop and soil carbon sequestration. Secondly, enhance air quality by capturing and diminishing dust levels. Thirdly, agriculture plays a pivotal role as a major source of employment and significantly contributes to economic growth. Lastly, promote the conservation of natural resources by optimizing land use to yield more food. Now, let's delve into the drawbacks. Agriculture imposes a considerable negative environmental impact in three main aspects. Firstly, water consumption. 70% of global freshwater withdrawals are allocated for agriculture. This water is utilized for various purposes, including irrigation, pesticide and fertilizer applications, crop cooling, and frost control. According to the United States Geological Survey, irrigation alone accounts for nearly 65% of the world's freshwater withdrawals. Certain foods have a substantial water footprint, consuming over 1,000 liters to produce 1 kilogram. Notable examples include cheese, 5,605 liters per kilogram, nuts, 4,134 liters, fish farmed, and prawns farmed around 3,500 to 3,700 liters, beef, dairy herd, 2,714 liters, rice, 2,248 liters, and various others. On the contrary, some foods have a lower water footprint, requiring less than 100 liters per kilogram. Cassava, for instance, requires almost no additional water, while onions and leeks, 14 liters, barley, 17 liters, coffee, soy milk, and root vegetables, around 26 to 28 liters, are among those with a relatively modest water demand. Aside from freshwater consumption, agriculture contributes to water pollution, particularly through eutrophication. This pollution phenomenon involves the introduction of nutrient-rich water into water bodies. Chemical fertilizers and animal manure, providing nitrogen and phosphorus, are major contributors. When these nutrients are not fully absorbed by crops, they can escape into water systems, adversely affecting air and downstream water quality. This excess nitrogen and phosphorus can be washed into waterways during rain events and snowmelts, or leach through the soil into groundwater over time. Eutrophication can lead to hypoxia, causing fish kills and a decline in aquatic life. Moreover, excess nutrients can trigger harmful algal blooms in freshwater systems, disrupting wildlife and producing toxins harmful to humans. According to scientific research, agriculture is responsible for 78% of global ocean and freshwater eutrophication. Examples include algal blooms in a river near Chengdu, Sichuan, China, Mono Lake in Mono County, California, a cyanobacteria-rich soda lake, and Valencia Lake in northern Venezuela, experiencing significant cultural eutrophication due to drained wastewater discharge. In terms of phosphate production, certain foods contribute significantly to phosphate emissions per kilogram. For instance, beef dairy herd produces 365.29, beef herd produces 301.41, fish farmed produces 235.12, and farmed prawns produce 227.22. This implies that for every kilogram consumed, a considerable amount of phosphate is released into the environment. Conversely, some foods have a lower phosphate footprint. Cassava, for example, produces 0.69, soy milk produces 1.6d, apples and root vegetables produce around 1.5 geg, and citrus fruit and other vegetables produce around 2.2. Vegetables and fruits generally contribute minimal amounts of phosphate, showcasing a more sustainable aspect. Secondly, greenhouse gas emissions. Global food production contributes significantly to greenhouse gas emissions, accounting for more than a quarter, 26% of the total. These emissions encompass a spectrum of activities such as land use change, on-farm production, processing, transport, packaging, and retail. Livestock, particularly ruminant livestock like cattle, play a prominent role, generating 30% of food emissions through processes that produce methane during digestion. Wild reserves contribute 1% primarily stemming from fuel consumption in fishing vessels. Crop production, covering both crops for human consumption and animal feed, constitutes a quarter of food emissions. Land use, responsible for 24% of food emissions, exhibits a noteworthy imbalance, with livestock-related land use emitting twice as much, 16% as land use for crops for human consumption, 8%. Supply chains, encompassing food processing, distribution, transport, packaging, and retail, contribute 18% to food emissions. Notably, plant-based foods generally exhibit emissions levels 10 to 50 times lower than their animal-based counterparts. According to Michael Clark and colleagues' model, emissions from food alone are projected to push global temperatures beyond 1.5 C or 2 C this century. For instance, emitting 500 billion tons of CO2 provides a 67% chance of staying below 1.5 C, which decreases to 50% with 705 billion tons. Intriguingly, emissions from food alone, predicted at 1.356 billion tonnes, are sufficient to surpass the 1.5 C target. Even if we were to cease burning fossil fuels abruptly, an impractical scenario, we would still overshoot the 1.5 C target and narrowly miss the 2 C target. Highlighting the emissions intensity per kilogram, certain foods stand out for emitting the most. Beef herd, 99.48 kilograms. Dark chocolate, 46.65 kilograms. Lamb and mutton, and beef, dairy herd, around 30–40 kilograms. Coffee, prawns, farmed, and cheese, around 20–30 kilograms. Conversely, some foods exhibit significantly lower emission levels per kilogram. Citrus fruit, 0.39 kilogram. Root vegetables, nuts, apples, potatoes, onions, and leeks, less than 0.5 kilogram. Brassicas, other vegetables, bananas, peas, soy milk, less than 1 kilogram. Thirdly, let's turn our attention to the critical aspect of land use. A staggering half of the world's habitable land is devoted to agriculture. This encompasses both pasture for livestock grazing and cropland dedicated to direct human consumption and animal feed. Astoundingly, 3/4 of this agricultural land is allocated to livestock, combining pasture and cropland for animal feed production. Consequently, this allocation provides only 18% of the global caloric intake and 37% of protein. The remaining quarter of land is designated for crops intended for human consumption, constituting the primary source of the world's calories and protein. Highlighting the land requirements per kilogram, certain foods demand more extensive land use. Lamb and mutton, nearly 370 square meters. Beef herd, 326 square meters. Cheese, 88 square meters. Dark chocolate, 69 square meters. Beef dairy herd, 43 square meters. Conversely, some foods demonstrate a significantly lower demand for land per kilogram. Root vegetables, other vegetables, onions, and leeks, less than 0.4 square meter. Brassicas, apples, soy milk, tomatoes, citrus fruit, potatoes, other fruit, less than 1 square meter. So, now that we've grasped the considerable impact of agriculture, it's evident that the negatives outweigh the positives, isn't it? However, the fascinating aspect is that understanding this impact empowers us to make changes for a better Earth. Real change begins with each individual, and collectively, we can minimize the negatives for the environment. That wraps up today's video content for part 1, and I truly hope it brought valuable insights to your sustainable journey. Don't forget to hit the like and subscribe button to YouTube. Spread this video to more people. Let's make sustainable living common knowledge. Earth will soon return to balance, and thanks to your meaningful actions. Goodbye, and I'll see you in the part 2 coming on next week.